Well, Matt knows what he's doing. So he says it.
All right. Good morning, everyone. Thank you all for joining, and it is our pleasure to have Marilyn Walker here today to talk about sentiment and sarcasm in online dialogue. So Marilyn is currently a professor of computer science, and she's heading the Natural Language and Dialogue Systems Lab in UCSantaCruz in the Baskin School of Engineering. Prior to that, she receives her PhD in computer science from University of Pennsylvania. She was a principal member of the research staff in AT&T Bell Labs and the AT&T Research Lab from 1996 to 2003. And after that, she was a professor of computer science in University of Sheffield until 2009.
Which university?
University of Sheffield.
Sheffield.
In the UK, yes. She has served. She served in the ACL community as ACL program chair for many years. She also she's on the funding board of the North American ACL, and she served to set up and orchestrate the first conferences between 1998 and 2001. She is the author of many research papers, over 200, and she has supervised 16 doctoral students and 30 undergraduate researchers. So we're very happy to have Marilyn here today. And Marilyn,
Thanks.
Go ahead.
Thank you. Hi. The title is a title I had to give like a month ago, and it's not actually very reflective of the talk. I am going to talk about online dialogue. I'm not really going to talk about sarcasm in this talk. I'll show you. I can show you some examples at the end, you know. But I decided that we're doing a lot of stuff right now, experiments on sarcasm. So I'm going to wait. You have to ask me back to talk to talk about sarcasm. So I just want to say a tiny little bit about Santa Cruz. It's been a really good. I've been there 6 years. It's been a really good match for me. I feel committed to the public university system in California, and I'm kind of proud of a lot of our statistics. Like we're #1 in social mobility in the world. 42% of last year's undergraduates were first in family to finish college. We have 30% female PhDs in computer science in the PhD graduate students in computer science. So we're kind of feel like we're making an impact, and I really feel like it's an environment in which I can make an impact. And I regularly have a lot of undergraduates working in my lab, and the stuff that I'm going to talk about today, these are the people that have contributed to it.
Yes? Were those statistics UCSC or UC?
UCSC, 42% of last year's graduating class first in family to go to college. So I feel really proud of being there, and I really like the environment. And so I'll tell you a little bit about the work that we're doing in my lab. You all know this, that, of the big data that's out there, a whole lot of it is natural language data. There's all kinds, and I love that poster. I'm going to have to get one of those over there, about the data. The data never sleeps. And, in general, what we're trying to do in natural language processing is to kind of make sense of this unstructured data. So we want to analyze it, infer new relations, organize it, integrate it with existing data. And my primary interest is not in like the newspaper text and security reports and things like that, but more in this user-generated content. I find it really fascinating, and for somebody like me who's been working on dialogue for 30 years or something like that, the fact that we have so much dialogue available now that we can work on is really very exciting. So I'm going to talk about opinionated dialogue online today. I'm going to focus pretty much on our work on opinionated dialogue. And I'm going to talk, we worked on a lot of different problems: stance, disagreement, argument mining, sarcasm, argumentation style. I'm going to focus today on the work we've done on stance and work on argument mining. And stance is what you want to know is like on an important topic, what is somebody's position on it? Are they for abortion or against abortion? Are they pro death penalty, against death penalty, gun control, against gun control? So that's what you want to know. And for the argument mining, this is a new area, and this is the first time I've actually talked about it in public. I mean, we have a couple of other previous papers, but I'm presenting some brand new results today that we're preparing for publication, so I'll be really interested in questions and feedback on that. So typically, we've done stuff with, who do they agree or disagree with and what's somebody's stance. But what we've been working on for over a year now is trying to figure out what exactly the disagreements are about. What kinds of particular arguments are people making in support of their position, and also how do the arguments change over time. So you might see, if you looked at, say, 20 years of discussions on gay marriage, you'd notice there's been some kind of tipping point in the last, just really like 3 years, where all of a sudden, one kind of argument for gay marriage kind of became very popular, and there was a whole tip, where like now the Supreme Court has said that, everybody has the rights to get married. And so our long-term goal would be to be able to track these different kinds of arguments that people are making for and against an issue over time and see how they change when new arguments or new themes come in. And then this other thing, which as I said, is false advertising. I'm not going to actually talk very much about sarcasm, but what's really interesting to me is that this language is really, really social. So about 10% of the utterances in our corpus are sarcastic, and they provide a lot of challenges for sentiment analysis. And at least 20% of it is very highly emotional. So if we have people rate arguments on a scale of from -5 is very emotional to +5 is highly factual. We have, at the tails of that distribution, we have really big chunks of stuff, and then there's a lot of stuff in the middle that's kind of mixed. So there's this very emotional argumentation, and you might think, what you want to do is just kind of get it out of there, like if you're trying to analyze what people are saying, but it's actually some of the most interesting part of the data, and it's what causes people to vote in a particular way and to hold certain kinds of beliefs. So I don't think you want to just have the assumption like, let's get rid of all that emotion and let's just look at at the logical argumentation. Okay, so I'm hoping somehow to talk a little bit about the way we're kind of curating this data and building it up. We have data. We have hundreds and thousands of discussions that represent millions of posts on almost any topic that a human could think of. We have this initial corpus release that we made 3 years ago called the Internet Argument Corpus. And we have a new release of that we're going to release in the spring, which is IAC 2.0, and that includes a whole lot of more scraped data from Create Debate, from Twitter, and from Reddit. And in the meantime, instead of just distributing JSON files, which is what we had before, we've structured this into an SQL database, and we have an underlying schema across all these different social media sites, so that for some queries where the tables are supported by the affordances of the site, you can pull in data from lots of different social media sites and use that in your analysis of the same kind. So you can do cross-domain analyses. You can see like what the difference is in the way that sarcasm is expressed on Reddit versus the way it's expressed in online forums or the way it's expressed on Twitter, for example.
What is IAC?
That's our name for our data, Internet Argument Corpus.
Okay, and what's CD?
Create Debate.
Okay.
And so here's, most of these sites are kind of like this. You have a person who wants to argue about something, and they post a topic like that, with a position abortion is legal and should stay legal, and then people kind of weigh in on the conversation. And a lot of times, sometimes the sites are very unstructured. You just get a thread structure, and there's no kind of more formal structure to the conversation. A lot of the sites have set up a pro and con side, and so people, when they post, they self-side for stance, right? So some of the data comes kind of self-annotated for stance. I'll show you an example in a minute. But what we do is that we take this data from all these different sites and we integrate it by topic, right? And this is a thing that we're still doing, that we do by hand. In fact, I'm the one who does it. Usually not any of my students. So they could go off busy running WECA, and I'll just, like in my copious spare time, I kind of pull up stuff from the data and figure out whether it fits in this topic and how to stance cite it. So the thing is, you get lots of different discussions that are framed in slightly different ways, and some of the same things come up over and over and over again in social media across all these different sites, like the death penalty. So they get framed in a different way, like, is the death penalty morally correct? Is it supposed to be in the United States? Or just something simply like capital punishment or death penalty injustice. And as you can see from the color coding there, if you want to combine those into a database where you can label them as being either for death penalty or against death penalty, you have to decide which of these statements on either side goes to which way. So that's something that we're doing by hand, which maybe in the future we could do automatically, but at the moment we're curating that data by hand, and so you get those topic labels and the stance labels when you download our data.
Occasionally nuance, it's not either pro or con, but somewhere in the middle, a little bit.
Well, see, it's easy to do for these sites where they force people to post on either side, because you can just kind of assume that they self-cited for stance, but there is noise in there, for sure. And then we have done analyses where we've tried to find posts where people stake out a middle position, and those are relatively rare. So I think that people that are undecided or that actually have a middle position actually are not posting. So what you get in the postings are you get kind of people that are really entrenched most of the time on one side of the thing, but you do get some stuff in the middle, and we have been able to find stuff in the middle. And we've tried to model, like how to get, yes?
Have you looked at people who've crossed over, who started Adamant 1?
This is what, like my colleague Pranav Anand, when we first started this project, whenever it was 5 years ago, he spent months looking at different sites trying to find what kind of topics people would actually change their mind. I just finally at one point I said, well, we have to spend $200,000 in the next 4 months, and so I'm starting to scrape. So, I said, whatever, we just have to, maybe it's not the perfect data, maybe we can find data. But we do have in the Reddit data now, we have that change my view Reddit, where people say like whether an argument actually changed their view, and that's something. But often what you see is you do see these nuanced positions, and we think if we do the argument analysis where we start to identify what the reasons are for somebody's stance, we might be able to more easily identify those middle positions. Like you might say, I believe conception begins at birth, but I still believe in a woman's right to choose. And usually people that hold those two beliefs are on opposite sides of an issue, but there's some people that kind of, what did I say, conception? No, life begins at conception. Life begins at conception, but I believe in a woman's right to choose. So usually if you believe that life begins at conception, you don't believe in abortion, right? So that there are some positions like that we've actually been able to find. And we're interested in finding those partly kind of to be able to reuse the data possibly for educational purposes. So I'm going to get way off my topic here, but there's evidence that shows that the more sides of an issue people are exposed to, the more holistic their view is, and the less likely they are to be entrenched in a particular position. So we have some kind of long-term goal of being able to kind of reuse some of these arguments once we can identify them in some kind of educational context. Okay, so is that all? That's all clear. Okay, so I think I already said most of this, why it's interesting. There's lots of applications. I just love this data, all the data that we can get. It has many unique properties. It's very social. It's very dialogic. There's lots of open research problems, and we've got an NSF medium that still has another couple years to run, and we're just curating this data. We're adding more stuff to it, doing more work with it all the time. And there's some of our papers. So first I'm going to talk about stance classification a little bit. I suppose I should, I don't know, I can't see a clock anywhere.
I'll tell you when you're 15
Half
minutes.
done?
Half done, and
Yeah.
then 15 minutes.
Okay, all right. So stance classification is the issue of taking somebody's posts or somebody's set of posts, you know, on an argument, and figuring out what side of an issue that they're on. And there's been a fair amount of work in this area, although, you know, the very first work in this area, you know, it's like 2003. There's been a fair amount of work since then, but not work exactly on data like ours. A lot of the stuff that's been done has been done on the U.S. congressional debates, but a lot of the data is not as dialogic as our data. It's not social. Yes?
Let me ask you a question. So you decide why is it interesting? So I certainly agree it's interesting, but why is it important? What impact will it have on the world to do this?
Well, I think there are a lot of, there's a lot of, first of all, there's just natural language processing techniques that can work on social data. So there's kind of an underlying technology thing. And any kind of social media data will need some of those language processing techniques. We have long-term broader impacts. We think it could be used for educational purposes. It also could be used for digital democracy, like you could mine the data that's out there and say, like, what are people saying about this issue? What are people in a particular region saying about this issue? How do people's stances differ across geographic areas? There's a lot of different kinds of things that you could do with the data.
Great, thanks.
So, okay, thank you for asking. All right, so on Convince Me, as I said, you know, it's set up like this, you know, that the stance is self-labeled. So somebody will post a topic like death penalty justice, and then they set up the conversation with two sides like this, you know. They should be put to death, yes, an eye for an eye, or they should have life in prison, right? And then people post, you know, on each side, and then you do get these kind of vote ups, you know, that was convincing to me, and you can vote, you know, vote for either side and stuff like that. We've done some work modeling some of this, and it's not clear that the convincingness or the efficacy of an argument is actually related to the upvotes. I mean, I can't remember the exact number, but it's like the R squared is like 0.11. You know, it's not very predictive of it. So on the Convince Me, we have all these different topics. Like I said, we have these kind of curated topics. So we have a massive amount of data that's not topic labeled, and then we have the data that's topic labeled and stance cited that's kind of within there, and I kind of continually do that. And we have topics that we consider to be kind of playful, like Star Wars versus Lord of the Rings, and technical, like Firefox versus IE or Mac versus PC. And then we have these what we call ideological topics, like abortion, climate change, death penalty, evolution. And you see quite a lot of differences. First of all, these topics tend to be across all kinds of different sites and be still discussed, you know, like over time. So what, you know, we would scrape stuff 4 years ago, and a lot of the same arguments would still be made now. And these dialogues are also more deeply embedded. People are more emotional. So if you just look at some kind of statistic like average post per person, these ideological ones have a lot more. Usually, like if you're going to say, you know, cats rule and dogs drool, you might just say that, you know, and you don't need to elaborate on it too much, right? So people in those, they're not as heavily invested. They don't kind of get so much into an argument, and hence the conversations are not so deeply embedded. And across these different topics, you know, if you just take the majority class, you'll see some of them are skewed, but many of them, you know, they're around 50-50. So you get about half the people posting on one side and half on the other. Yes? Did you have another question?
Do people post an anti-evolution a lot? I mean, I would think those folks would post a lot.
Half and half. Well,
Really?
15,
Wow.
yeah.
Okay.
So that's one of the points I want to make, actually, is if you just go to a curated argument, like if you go to a site that's like an official debate site where somebody scientific has curated an argument, there's a whole lot of arguments here that you would never ever see on a site like that, right? Because they're not considered to be rational or something.
Yeah, Ron, was your point that those people don't exist, or that they wouldn't make those arguments in public?
It wouldn't make the arguments in public, because they wouldn't have arguments, they just say,
Because
I
there
don't
aren't.
believe it.
It's evidence
They're
versus
not
faith.
that smart, though.
They're not that
They're
smart.
not that smart.
I have one example in my sarcasm stuff. If I get to the end, you'll get to see a sarcastic anti-evolution post So anyway, the first thing that we did with this data was that the other work that had been done before us on stance had never said, like, and a lot of it had treated it not as dialogic. They just take the post out of the blue and then they'd done, kind of text classification on it. And nobody had ever established what the human talk line was for that kind of situation where you just show somebody a text, a post out of a dialogue, out of the blue, and you say, this is the issue that's being discussed, these are the sides, which side is this post on, right? So we were kind of surprised. We were surprised that nobody had done it, and we were also surprised that the numbers, the accuracy that people were getting who were working on this problem, that they were so bad. We're like looking at the data and we're thinking, why is this so bad? Why is it average like 64% over 50% baseline? Why is 70% the best that you could do on any topic? It didn't make any sense to us in the beginning, right?
What was your gold standard to decide what the correct answer was? Because you said people were
Oh,
wrong,
we use a
that was right.
majority class. Usually on this particular thing, we had 9. This is one of the first mechanical Turk hits that we'd ever done. And we were influenced by this Snow et al. Paper from Stanford that had looked at, it's called something like Fast and Cheap, but is it good? And they had shown that, if you had 9 annotators for a whole bunch of different tasks, that, by the time you had 9, that was as good as having an expert or something like that. So that's what we did. We just said 9 people, and then we took 5 out of 9 or 6 out of 9 said it was on one side. And there aren't that many. I don't have the distribution in here anymore, but there aren't that many cases where people really are, where you get like a 50-50 thing between 9 Turkers, right? Most of the time that it goes one way or the other. It's pretty clear.
Unless there is sarcasm involved, and it's hard to.
Huh?
Unless there is sarcasm.
Yes,
involved.
sarcasm, and I'm going to show you a particular case. So this is what's interesting that the human top line pointed us to. Rebuttals are things that are dialogically threaded on convince me, and the non-rebuttals are more like monologic posts that stand alone, right? So if you, this shows that on the human top line, the human is only getting 73% accuracy on posts that come from a threaded conversation. Whereas if they don't come from a threaded conversation, they're getting 87% accuracy. So like an initial post in a whole thread that just, somebody's making their first argument, those posts are easy to decide, or ones where they're not directly rebutting something else. But this shows the effect of context, that the context is really important, and that without the context for a lot of these, you can't actually tell what side somebody's on, right? So humans are, do more poorly at classifying rebuttals, and they also, like when we have that split between ideological and non-ideological posts, they also, for the non-ideological posts, they can cite them correctly 85% of the time, but for the ideological ones, only 76% of the time. So it's clear that context is having an effect, and this thing about ideological versus non-ideological, it may simply reflect the fact that the ideological discussions are more deeply nested. So this is a little example to kind of talk you through like how you can use context better to understand these from an algorithm perspective. So say this is the post, and this is a death penalty post. So that's your evidence, what happened to those studies in the late 90s. A lot of things were different than the periods preceding and following the one you mentioned. We have no way to determine what of those contributed to a lower murder rate, if indeed there was one. You have to prove a cause and effect relationship, and you have failed. So what side do you think that's on? For death penalty or against death penalty?
Against.
Yes. But it's not obvious, right? It's not real obvious. So if you look at the parent post that's being rebutted against for that, right? So this is a rebuttal link here. You just get a URL, and we made this decision that we were not going to scrape and analyze URLs that were pointed to a single post. So that to us gives us really no information, the way we're modeling it, right? But if we go further back in the conversational thread, we find out that this link between those two posts is that they're the same author, right? And that post is very clearly pro-death penalty. This person is saying if you kill people, then it acts as a deterrent, and people can't go out and commit more crimes, and so it's really good to kill people. right? So when we have this whole network, it's very easy for us to finally conclude that this post is anti-death penalty. So we use a graph-based algorithm called max-cut, which probably a lot of you use in your work regularly anyway, but I'm still going to go through it for those that don't. So first, what we do is we use the reply structure to separate participants into two groups with the opposite stance. Then we use the text of the post, the out-of-the-blue text, to determine the stance of individual posts. And then we use the labels from step 2 to orient the partitions from step 1. So even once you have a partition in a graph and you have a lot of posts on either side of it, you still have to decide which side is pro and which side is con, right? And so you build a big graph where you have like different kinds of edges between nodes. So the nodes are the posts, and the edges represent whether it's the same author or if it's a rebuttal. And max-cut tries to, this is all said here probably better than I can say it off the top of my head. So the nodes represent the posts, the edges represent the relationships between the posts, and the edge weights can be positive or negative. So if it has a positive edge weight, it rewards the algorithm for cutting that edge because the algorithm's trying to maximize the weight of the edges that it cuts. And if it has a negative edge weight, it punishes the algorithm for cutting that edge and says, keep these things, try to keep these things together. And in the end, when you get all those weights and everything, then there's a kind of heuristic approximation of the procedure that will figure out one cut on the graph. And this is an NP complete algorithm, but there are tools out there that implement good approximations for it, which we used an off-the-shelf tool, but I think its name was something called Big Max Q or something like that. Yeah?
Along these lines, have you tracked an individual's opinion on many topics such that, for example, if
like ideology?
Well, if you take a user and look at many topics.
There is a paper that does that. It's it says, the idea is like if you believe in God, you might be pro-death penalty.
Right.
Which actually is true. I mean, there's a statistical correlation between those things. So
what I'm wondering is, could you reduce it down to if you ask someone's opinion on 3 topics,
you could predict all the others?
Exactly.
I'm not sure if that's true. It's more like there's like 70%, 65% correlation that, something like 65% of the people that believe in God are, pro-death penalty or, right? So it's not absolute.
Okay.
And there's a paper from UT Dallas that is one of the first papers to kind of look at this ideology thing. And then I did some work with Lisa Gator last year where we kind of did a joint model between stance and disagreement. And we tried to, in probabilistic soft logic, which is her modeling framework, her graphical modeling framework, we tried to put ideology in there and we didn't get any feedback from it. So we haven't returned to that again.
If you have determined a stance of a topic and you are not sure because it's ambiguous, can you also use relationship to other topics that you are for sure that people agrees to some other people that has a definite stance on something else? And
that we haven't. So you say in terms of alignment between the
right,
people.
you don't know what this person is.
We haven't done
what's
that.
the
It's
stance.
a good idea.
Okay.
So you say if they agree on abortion, they're probably going to agree on.
If they agree in different topics, maybe that can tell you in which way they are heading with that statement that
It's
you're
a
not
good
sure.
idea. We haven't done that. Yeah. Anyway, this part is just a supervised classifier. So once you have a cut in the graph, you classify all the posts on either side of the cut, and then you use the margins. You sum up the margins, and you say, okay, I think this side is pro, and this side is con. So just let me show you. Am I half through yet?
No, you have.
Yeah. Okay. Well, I'm just running like 2 minutes behind. Okay. For the supervised classifier in this out of the blue, over the what you get by chance, it's really bad, right? So this is like without any context. I mean, you could say, oh, you guys are stupid. You don't have good features. Maybe you could do better, you should do more feature engineering, but we put a whole lot of stuff in there, and it's not very good. And we tried a whole bunch of different learners, and we had a collaborator at Naval Postgraduate School who did grid search for us for SVM, so we tried SVM with all these different parameters, and basically in this out of the blue kind of context, we just didn't do very well. But what's really interesting is that the max cut kind of applied in a simple way, like I said, using an off-the-shelf max cut tool, and not having a very good base classifier. When you bring in this contextual information, we got these huge improvements overall, right? So for abortion, we went from 55%, say, to 82% accuracy on the post level, and we have some very, very good results, and we also have some that are bad, and those bad ones, you might have zeroed in on them. Those bad ones are because we oriented the partitions, after we made the partitions, we oriented them the wrong way, and that shows that there's this very weak base classifier. It's just not very good. But overall, if we just take the weighted average of the accuracies according to the size of the topic across all the posts, overall we get a increase of 14.2% overall, averaged over all the topics. So even when we have some of the partitions are going the wrong way, we still get a very large overall improvement by using a graph algorithm to model it. Did you have a question? You? Yeah. No? Okay. No, him back there. Okay, so now I'm going to move on to the second part, and like I said, this is, we've had a couple papers on this. This is the first time I put these things together in a talk, and so it's a little, that's why I took an opportunity. I thought, oh, this is a really good chance, to see what a bunch of smart people think about something that I'm really starting to feel good about. So give me your comments. I'd be really interested. So what we're doing here is we're trying to address this problem of what are the arguments that people are making, and so kind of a causal relation, like why do they hold a particular stance, and it could also be related to that thing of finding these people that stake out these middle positions by bringing in arguments that are normally associated with one side or the other, right? So there are on these websites that we've scraped, there is this idea of an argument facet, and an argument facet is a type of argument, not a token. It's a type of an argument that is repeated all the time by different people in different contexts. That's what a facet is. So if you look at death penalty, for example, you see this thing said lots and lots of different ways with lots of different paraphrases that the death penalty is a crime deterrent, right? You see things that say, it prevents them from committing further crimes, it takes care of our prison crowding problem, it helps the victims' families achieve closure. So you see those same arguments repeated over and over again. And on some of these sites, these are the curated by experts, somebody who wants to teach school children what the arguments are, will produce these kind of curated arguments, and then people can kind of look at them, right? And so here's some definitions for you. So our thought is that when people have different stances, you don't want to treat a whole post as kind of just one thing. There's lots of little arguments in there, and over the course of a dialogue, they might produce different arguments at different points in time. And so what you want to do is you want to figure out exactly what are the points of contention, what are the things that people are disagreeing about. And some of those things will be factual, right? Like, is the death penalty actually a deterrent, right? Is it really a deterrent? So we call these things these kind of tokens of repeated arguments. We call those the central propositions or the central arguments. So those are at an individual dialogue level. The facets are the central propositions that kind of get repeated over a whole bunch of dialogues on a topic. And we've defined this new task, and I'll explain why in a minute, of argument facet similarity. So what it does is it aims to identify when two tokens, two paraphrases of an argument are actually quite similar to each other and realize the same facet. So it's a kind of paraphrase problem. And as I said, these other sites, one of the things that I want to point out, I'm going to get to in a minute with the limitations, is that, so iDebate, which is that site, has like 5 things on each side. right? It pulls out as being the kind of core arguments on either side. Procon.org has top 10 pros and cons for the death penalty. Some of them are in overlap with the ones on iDebate. Some of them are slightly different. And their arguments, they have these detailed arguments for them that cite constitutional law and different kinds of things. So this is really kind of highly curated. And we discovered when we were trying to use their facets to label our data, that in the middle, in a 3-month period, somebody completely reorganized the top 10 pros and cons on a particular topic, and the facets that we were using were suddenly changed and they weren't there on the site anymore. And so that was very informative for us, was there's kind of no truth in this, really, like what the important facets of an argument are. And that's partly what led to this idea that we have that, or made us think again, that clearly the arguments for and against something change over time. So here's some examples of things that we think are similar facets. So here's an argument that gets made in the gun control. Guns are just like cars. They were invented to do what the owner wants to use them for, and there's no difference between a gun and a car. And then the other person rebuts that by saying, but guns are weapons. They are actually made for war, right? To kill. They're made to kill, right? So there is a difference between a gun and a car. If you kill somebody with a car, it's an accident. If you kill somebody with a gun, it's probably not so much, it could be an accident, but probably not so much an accident, right? And here's a different framing, kind of the same, of what we believe is the same facet, is to say, well, the U.S. clearly has a violence problem. There's too much violence in the United States. It has nothing to do with guns. Guns are just tools. Guns are just tools, that people have for different things, and it's got no, violence and murder and all those things, they don't have anything to do with the prevalence of guns, right? So those are some arguments. We also get this stuff. I could tell you how many instances there are of this argument. You can kill a person with your bare hands. You can kill a person with a baseball bat. A person can drown in an inch of water. You can kill a person with a hat pin. You can, I could tell you how many different instances of this thing there is in our data, right? So this is, it kind of gets repeated all over the place. So in gay marriage, too, you kind of obviously you're going to see the same thing. There's this civil rights argument for gay marriage. There's like a religious argument often against it. There's a civil rights argument for it. And this thing, my family, if her religion gets made into law, it bars my family from the legal protection. It's a civil rights issue. Gay marriage is a civil rights issue, right? And you see the same argument again. It's the civil benefits that are at issue. We're not looking for religion. We're looking for civil legal benefits. And then you get this whole list of all the benefits that are automatically accorded to people that are married that, would automatically go to gay couples if they were allowed to marry as well, right? So anyway, so those are the kinds of things. And we framed this as consisting of 3 steps in order to try to find these arguments and group them into facets. And I'm going to explain why we want to do it in a bottom-up way. So, so the idea first is that we want to go into the post and we want to find the phrases that clearly state an argument. And then, once we found a whole bunch of those things, then we want to group them by how similar they are to other instances, so we have a metric for argument facet similarity that we want to apply. And once we have a good similarity metric, we should be able to group arguments into facets, and then even though we don't have a label, we could use like a centroid of that cluster as the label for the thing, right? That's kind of the idea. So the first step, the argument extraction step, is to find and extract the central propositions from a large corpus of topic-sorted dialogues. And we've tried 3 different ways to do this. So the first idea was, if you give dialogues to a human and you tell them, give me a summary of 100 words or less of this dialogue, any native speaker of the language or somebody with language competence will actually pick out the things that are at issue. They'll just zero in on them, and they don't have to have any training. They'll just go in and find them. And so we wanted the task to be framed in such a way that we could put on Mechanical Turk. We have a set of qualified Turkers now that do dialogue summaries for us, and we think that the summaries are pretty high quality. Yes?
Can a facet have sub-facets, or are they atomic?
They could they could have subfacets, and that's part of the reason why we're trying to model it as this not categorical thing. I think that's on the, where is that? Somehow my related work slide is missing. Oh, I know where it is. It's in with the argument facet part. I'll show you. Okay. Well, I could go ahead and see. Most of the previous work treated it as a supervised learning approach, where there were these labels, like from iDebate, or the annotators kind of got together and agreed what the facets were, and then they all labeled the data. And that treats the facet as being categorical, as atomic, is your word. And but we don't believe it's categorical. We think that there's these relationships between facets, and facets can be in overlap, and so the idea of similarity is, textual similarity or argument facet similarity. We believe it captures the nature of the data in a much better way than this kind of categorical notion. Okay, so, oops, I'm going the wrong way. There. Okay, so human summarization, that's what I do. We have a corpus of human summaries. And we have one paper where we use the summaries to try to see what kind of facets came out of the human summaries. When we have a paper at SIGDIAL from last year where the idea was, we thought that, we have all these argumentative discourse cues in our data, and we thought that they're kind of implicit markup by the participant. Like if I say because, because I said so, right? Or because it's not a deterrent or whatever, then I thought the idea was that these kind of causal markers that mark the reasoning would mark, that their dependent clause would be an argument. And that kind of worked, but not very well. And so then we have this sentence selection approach that we've just got these results for like 2 weeks ago, where I'm characterizing it as brute force, where we just keep developing features and figure out like what we're getting, why we're getting stuff we don't want, and then so I'll show you. So we've tried these 3 different approaches, and here's kind of what the summaries look like of that. So this is one of those dialogue part. The segment that I showed you about gay marriage is part of the dialogue that this summary is about. These 2 summaries, right? So people do. They do say other stuff. The thing about the human summaries is they kind of pick out like what the important facets are, but they also, the thing about the human summaries is that they use context, so you can't interpret them directly, and they, sometimes some people are longer, some people are shorter, so we've experimented with saying like make it 50 words, make it 100 words, make it 150 words. But anyway, we have these summaries, and we've done this pyramid approach with them, which is an idea from information retrieval. Who's familiar with this? It's like track evaluation for summary production. Okay, well the idea with this is that you have end summaries, and you look across the end summaries, and you have an annotator actually produce the kind of like a facet label, right? Like a facet label is that gay couples are interested in the rights and benefits associated with marriage. So these SCU labels are produced by a human annotator, and then they look at all the summaries across the dialogue, and they say, with this tool, was that facet used in that summary, right? So then you get this idea of a tier, which is like how important that content is in the summary. And it was used in TREC. It's developed at Columbia. It's used in TREC to do evaluation of summaries, machine-produced summaries. And so we're applying it here to these human summaries, and we're using the tiers to tell us like which of the things that are in a summary are the ones that are repeated across different summarizers that seem to be more important in the dialogue. And so these dialogues, these summaries, we have them available. So this sentence selection model is the stuff that we've been working on over the summer and fall. So we had this model from SIGDIAL that was supposed to do sentence selection, argument extraction, and it kind of worked, but it was still, there was a lot of noise in the data that we were getting. Certainly it wasn't good enough to like use for the next phase without human refinement. So what we did is we took that model that we had, and we applied it to predict argument quality. And then we took all the stuff that was kind of in the top part of the distribution, everything that was above 0.55, and we didn't go higher because we were worried that we would reduce our recall. That we would, if we, for example, only took stuff that was 0.85 and above, we would just get the same arguments over and over again that were repeated, that were the most frequent, and we would miss out on arguments that were more unusual and represented more like the full breadth of the argumentation. So we went down to 0.55, we binned them into 5 bins, and then we did a task to evaluate we applied more filters. So this is what I say is kind of brute force. Really, we kept saying, oh, we're not getting what we want, we're not getting what we want, we're getting stuff that doesn't have a verb, we're getting stuff that has too many non-English words, we're getting, and so we kind of refined it. And then we did a mechanical Turk task where just a binary task of, does this sentence express an argument, a clearly defined argument or not? And I'm pretty happy with these results that we finally got. So these are like some examples of things that we're pulling out on the gun control debate. If gun bans work, there'd be no gun deaths in the countries that have banned guns. Gun haters will just do anything, to take away our constitutional rights. Right, so we get, we get a lot of the stuff that we expect to get for gun control, which is something we actually know quite a lot about now because we've got like 37,000 posts and we've been working on it. And this is what happens, so the prediction, our previous prediction score, was wasn't very good. Those are the bins. This bin range is from the SIGDIAL model, and then you see that we're starting to get a lot of, actually I said that wrong. This is the new bin range, right? So we're starting to get a lot of stuff that is better, right? So we decided, well, now we can go ahead. We have something, we still don't know, we don't really know, we haven't tried to quantify what the recall is. Like, are we missing out arguments that are less frequent that people aren't making? We haven't tried to quantify that yet. Yeah?
Did you always start with topics, or did you also detect topics that people are?
No, we've started with topics here. I think a lot of times you could get rough topic groupings, actually scrape them off the sites because people have to put things under, like this is a social topic, and also topic classification is more, a lot of people think it's unsupervised topic classification is a solved problem. I'm not sure I completely agree, but I'm not going to work on it.
What is
yes?
SIGDIAL, special interest group on what?
Sorry?
What is SIGDIAL?
Special interest group on discourse and dialogue. So it's people interested in language and context.
Okay, good.
It's a sub-sig of the Association of Computational Linguistics.
So dial is dialogue. basically.
Yeah, it's single, like ACL, I don't know if you went to ACL 20 years ago or whatever, but it used to be, single thread and everybody was there for every session and everybody heard all the papers on all the topics. And it's nothing like that anymore. It was 4 parallel sessions and a poster session going all the time and everything like that. But SIGDIAL is still like single session. And so it's kind of a nice little venue if you really want to look at like language and context. Okay, so I feel pretty good about this. And we've applied it to 4 or 5 different topics now, and we're, so now we're going to move to now we're kind of moving to, 10 minutes, okay. So now we have those arguments and we're trying to figure out which ones should be kind of grouped together and said that they're part of the same facet. So I already got to say this earlier because Ron asked me this question. So I already said that earlier, that this is primarily what other people have done. It's this supervised learning that's categorical and they put these labels on and we don't like it, right? We don't like it for a whole bunch of reasons. It's specific to the existing data and the topic at the time. If you see unusual arguments, they just get thrown into a bin. If they don't fit in the labeling that you have, the professionally curated arguments that are sometimes used for labels might not capture what people are saying. Like, I don't think you're going to find on one of those professionally curated sites the argument that you can kill somebody with a hat pin. The arguments are sometimes related, they're not categorical, and then I believe, although I haven't shown it, that new arguments kind of arise over time and there's new things. Like, imagine that the argument that death penalty is cruel and unusual punishment. Just imagine it had never been made, right? And then you have those botched executions in Oklahoma, and all of a sudden that argument's everywhere. Everybody's saying, so either the frequency of a particular argument will change over time as events happen in the public sphere, or actually I believe new arguments will come up. So probably, 30 years ago, the argument that we should have a wall between us and Mexico, that argument, maybe nobody had made that argument yet. They might have said that, we don't want to let Mexicans in because they're bringing cholera into the country, but nobody had this great idea that we could build, a 30-foot wall and that would solve all the problems, right? So we do believe that there are, these new arguments coming in all the time, and even if you think they're irrational, you think they're crazy, or they would never occur on a professionally curated site, you want to know what people are saying, right? What are people actually saying? What do they actually believe? So anyway, we feel like this approach, this kind of unsupervised bottom-up induction approach, is a better fit to the problem. And it's kind of like paraphrase detection or learning, and it's also quite similar to this semantic textual similarity task that they've been doing in the semi-val workshops over the last few years, which says the degree to which two phrases or sentences mean the same thing. So our argument facet similarity task is different than, but kind of inspired by this semantic textual similarity task. And we collected judgments for argument facet similarity on a scale on Mechanical Turk. We've done it on both the human summaries and on our sentence extraction cases. This is our NACL paper from last year. We used this semantic textual similarity baseline from University of Maryland, which won the 2013 semi-val contest, and they have it out. They have it on the web. They restrict you to so many queries. So when we want to get their baseline, sometimes it takes us a couple weeks for this, to get it for this task, because they don't give you the software. You just have to keep pinging their website. But anyway, we got results. We got an R of 0.54, which was significantly better than that baseline, and we tried a bunch of different features. So that was one result that we got. That was with the human summaries. And then I'm going to skip over this because this is just a bunch of examples of how argument facet similarity ranges over different kinds of pairs of arguments. And we can go back to that in the questions if anybody wants to see. So this is the stuff from our sentence selection, which, as I said, we just finished running a couple weeks ago. So we have the sentence selection arguments, and we take them all, and we have some training data saying how similar are these two arguments. But all the features that we use, we believe, are topic independent. So we have like a corpus of topic sorted dialogues, and we get the PMI of certain n-grams, and then we have a feature that's PMI weighted n-grams. And so we believe, although I don't have any results here showing it, we believe that the way we're doing this is topic independent. And so you have a pair of things, and there's a Mechanical Turk prediction and our trained argument facet similarity predictor. And right now we've got our best R is 0.66 with our RMS of 0.78, and Rouge is interestingly our best competitor on that. It beats out, because Rouge is a translation metric, it beats out the semantic textual similarity thing. Our task it's different, and the data that's been used for this semantic textual similarity task is so much easier than our data. The sentences are shorter, the vocabulary is more restricted. It's not surprising that their thing doesn't do that well on it, but that particular system, it has everything in it that you could ever possibly imagine as like a technical approach. It's got alignment, it's got distributionally similar words, it's got all this other stuff, but it's not trained on our data. And we have probably a lot of the same underlying features in our model. And anyway, so that's our best result as of 5 days ago.
So is a task to predict the similarity
Yeah.
based on features you define?
Yeah, so we take these things, we have a bunch of features, like PMI, n-gram overlap, distributionally similar words. Probably we have sentence length in there. We have, I can't even remember. I mean, we have a bunch of stuff in there, like, kitchen sink. And then we have some training data that predicts argument facet similarity. It doesn't use any topic-specific features. The Sigdal paper that we've already published compares topic-specific, it has some topic-specific features in it and compares what you get for topic-specific features versus ones that aren't topic-specific. But this is all with, there aren't any topic-specific features in here. They're all meant to be general across topic. Yes?
So speaking of that, do you use any deep parsing like features?
Oh, we have word to vec. Yeah. In the Sigdal paper, it didn't help, but I think in this, it's in there in the proposed model, and I think, I can't say for sure, but I think that Amita told me that it's helping now, and I'm not sure why it didn't help before with in the previous studies. Maybe we didn't have enough data, or I don't know. It could have been that the word to vec that Reed used was trained on the wrong corpus, or I don't know. But anyway, it's helping now.
Can you talk a little bit about the second one there, or third one, Luke?
Oh, Luke is an off-the-shelf dictionary that's developed by James Pennebaker, who's a psychologist at UT, and it has different word categories. So it has categories of words like cognitive mechanism, negative emotion, positive emotion. It's quite a common tool.
You
And
use the categories, Luke categories, and
we
words
take,
as
actually,
feature?
yeah, we could use their tool, but we don't. We buy a copy of their tool every time a new version comes out. And then we use the dictionary in our own tool. So it's an amazingly hard baseline to beat for a lot of these sentiment tasks that we do. It captures a lot of stuff, and we have code to develop Luke generalized dependencies. So you could say, like, this is a negative emotion word, and you could leave some part of it lexicalized and have some part of it generalized. So you could say this is a negative emotion word, but its target is, a family member, right? Or this is a positive emotion word, and its target is a category of sports events, or those kinds of generalizations you could make across a whole bunch of data. It's quite useful. Yeah.
Could you elaborate a little bit more on the motivation of predicting the similarity? I can always to represent the original argument in certain maybe more complicated representation and calculate their similarity using, for example, some defined distance. And here you're trying to predict the similarity based on the features.
Mm-hmm.
Why you want to?
Why do we want to do that?
Yeah.
So that we can do this facet induction. But we don't think that the facets are categorical, so we want a scalar thing where you could do kind of like hierarchical agglomerative clustering, and you can say that these are like little subfacets and then this is a superfacet of that, and kind of group things together. We also think you could have an interface where you could say, like, here's an argument, find me some similar arguments, right? And it would be